You also have learned the preparation of solution, right? Right. I
Yes,
want to
doctor.
ask a question. Okay, you have learned that preparation of solution, M1
Yes,
V1.
doctor.
What about the percentage? Sorry. Volume to volume percentage. Week per volume percentage. Week per week percentage. Week by week or week per week. We can say that. You have learned that. Huh. Dr.
Yes,
Aida is
doctor.
there. Dr. Aida, I just want to refresh and recall back what they have learned. Okay. Let's answer this question. Right. How to prepare 25 ml of 0.01 glutamic acid solution from a glutamic acid powder. The molecular weight for the glutamic acid is 147.13 gram per mole. Okay, how to prepare 0.01 molar of glutamic acid. I give you about 3 minutes. Can? All right, done.
Yes, doctor.
Okay. Anyone want to share their calculation?
Actually, I did it in my calculator. Can I just explain it here?
Yes, Paklit. Yes, please explain.
Okay, so 0.01 m is
Yes.
in the mole per liter.
Yes.
So we will calculate using, since we're using we have to prepare 25 milliliter. We
Yes.
take 25 divided by 1000
Okay.
and times 0.01,
So
and we will times 147.13, which is one more.
right, I want to know why we times, we divide or something like that. For example, okay,
yeah.
the first thing we want to acquire the number of mole first. Example, explain like that so that
Yes,
we
sir.
all learn from
So first we have to calculate for the mass that we have to
All right, Max.
put in the solution.
Okay.
So after calculation, we get 0.0368 grams,
Okay.
and we dissolve it in
Okay.
around 10 to 20 milliliters.
Around.
Around 10 to 20 milliliters, and we fill up. If we are using the volumetric
You are
flask.
using the volumetric flask.
Yes, doctor.
All right, good. That is a very
So fill up to the mark.
a very practical procedure to prepare. Okay, if you have done that in the lab, you have the volumetric flask. You need to fill up the water, okay, or the any solvent that you want to use before the the marking, okay, the marking that showing the final volume. So we need to put before the marking first, right? If you can imagine the volumetric flask, okay, and then so that you will fill up, right, until the final volume. So that is what Supaklit want to explain us, right? Okay, this is the calculation, right? 0.01 mole per liter times, okay, 147.13 gram per mole, right, times the volume. So the what is that the answer that you get?
0.0368
The gram,
grams.
okay. How many gram?
0.0368 grams.
All right. So that is the amount of the mass of the glutamic acid powder that need to put in the volumetric flask and then fill up to the mark. All right. I think we have done some revision. Okay. So now I would like to start our lecture for this class. Starting with the first modern technique, which is the spectroscopy method. Okay, spectroscopy based methods. Right. We have spectroscopy. We have what else? What kind of methods that we have in the in analytical chemistry? The modern methods we have learned, right? What is other than spectroscopy?
Gravimetric method and electroanalytical method.
Okay, volumetric is we call as the traditional methods in analytical chemistry. The modern methods is like spectroscopy, right? And then separation or chromatography, okay, chromatography technique. And then we have electroanalytical technique, right? And so on. That is the modern methods we are using instruments. If the classical methods, we want to analyze, for example, metals in solution, we have volumetric methods. We need to do the calculation involving the volume, using titration and so on. That is a very classic technique, involve a lot of steps. Okay, before we have the modern techniques using the instruments. We have also gravimetric techniques. We must mix all the sample with the some kind of the reactant, right? And then we will get the precipitate, and we measure the weight of this precipitate. Then we know how much is the metal inside. So that's very, messy, right? And very a lot of steps involved in the technique. A lot of using in lot of chemicals that we need to add and something involving the labs, wet labs, all right. But now we have a lot of analytical instruments that have been invented. Okay, so one of the methods, okay, for the modern analytical chemistry is the spectroscopy based methods, right? The word spectroscopy, your idea, what is your idea about the spectroscopy? What is the meaning behind the word spectroscopy? Spectro, what is spectro? Based on what? Any idea?
Radiation wave.
Sorry, okay, I forgot to record. So now we are recording. Okay, we start our lecture on the spectroscopy based method. What is your idea? What is the the hidden terminology behind the word spectroscopy? Okay, just now who said?
Yeah.
What's that?
Radiation wave.
Yeah, okay, yeah. Radiation, right? A good keyword, radiation. And then from who's that? Doctor, sorry, but just not remind to record. Yeah, sorry. I just have the ilham to record right now. So I just record. I forgot to record actually. All right. So it's okay. Previously we just do some revision. This is our new topic, right? Thank you, Afika. All right. And then from Woon. Okay, light transmittance, right? It's good. It's good keywords. It's about light transmittance. From who? Wavelength. Also perfect keyword. Wavelength. Spectrum. Yes, Edward. Spectrum. Spectro come from the word spectrum. Okay. Radiation. All right. Good. Okay. What else?
Absorption pattern.
Absorption.
Yes, doctor.
All right. Good. Good. Absorption. Meaning that you have to do some revision there. Okay. What else? Come from your mind when we we learn about spectroscopy. When you first time heard about spectroscopy, right? Electrons, ions, yes, involving electrons as well. Frequency, right? That is the keywords behind the word spectrum, light, right? Transmittance, radiation, wavelength. Okay, that is the idea behind the spectroscopy based method. It is based on light or is based on radiation. Okay, spectrum. Okay, good. Okay, before that, before I go further, me and Dr. Aida would like to have some survey. Are all of you in UTM right now, or you just at your home? Especially to our foreigners, for our international students.
Still in own country, doctor.
Who's that? Supaklit or who's
Doctor.
speaking? Sorry,
Supaklit, doctor.
Supaklit. Okay, you are at your country, Bangkok, Thailand.
Thailand, doctor.
All right, you are at Thailand right now. So, who else? Bara, where are you, Bara? Right to outside Malaysia. Where are you? Dubai? Turkey. Okay, Bara from Turkey. And then who else from not from Malaysia? Outside Malaysia.
Doctor, I am in Somalia.
Who's that?
Muhammad Abdullahi.
Muhammad?
Abdullahi.
Muhammad Abdullahi. You are
Yes.
at where?
Somalia.
Somalia right now.
Yes.
So our international friends, Sufaklit at Thailand, Bara, Turkey, Muhammad Abdullahi is at Somalia. So who else? May I know?
Doctor, I'm in Saudi right now.
Who's that talking? Who's that speaking?
Awad Salim.
Sorry, what's your name? Awad?
Awad Salim. Yes.
Awad, okay. Awad, or Awad Al-Bathani. Is that?
Yes.
Okay. So you are at Saudi Arabia.
Yes.
All right. Who else?
I'm Nabila. I'm in Indonesian right now, doctor.
Who's that talking? Sorry.
Nabila. I'm in
Nabila
Indonesian
is
right
at Indonesia right now.
Yes.
Okay. Oh, what's that sound? Is that your puppy? All right. So, Dr. Aida, are you here, Dr. Aida?
Ada. As you can see,
Dr. Aida.
under the research,
Yeah.
Okay. Who's speaking?
Aida.
Oh, Aida. Okay. Dr. Aida, can you make a simple Google Form survey for our students? Asking them what is their, their name, their matrix number. Of course, they are from our section. Okay, their matrix number and their course and year. Okay, course and year. Sorry, not course, program and year. And then what is their country, origin country, and where do they stay right now, and when they plan to come to Malaysia. Okay, for your information, Dr. Aida, can we tell all the students about that circular?
Sure.
All right. So for information, the class should be face to face starting from May, or basically after the mid-sem break. We just know about that yesterday, right, Dr. Aida? Yesterday. We need to do the face-to-face class starting after the mid-sem break. I think, what is that, Dr. Aida? When is that? 9th of May or something like that?
8th of
Yes,
May.
9th of May.
9th of May, yes.
After 9th of May.
So 9th of May is, what day is 9th of May? It is Monday. So our class will be on Tuesday and Wednesday, right? So by hook or by crook, we have been told that we need to do the face-to-face class starting from 10th of May. In case this is for the case of our course. The circular said that from 9th of May, but our class start from 10th of May. So we should do face-to-face class from 10th of May and onwards, right? Some of you sad and some of you happy. A mix of emotion there. Okay. Right, guys. As for your information also, starting from 1st of April 2022, the government of Malaysia have declared that the pandemic stage of COVID-19 have been ended in Malaysia, and it is now the transition stage to endemic. Okay, not fully endemic, but normal pandemic. It is transition stage to endemic of COVID-19, and as you all know, in Malaysia, all schools have been operated as well. The school students, school children, okay, they go to school now to have a face-to-face class, and why not for us in university? Okay, so that's why the Ministry of Higher Education have decided that actually next semester is full face-to-face class, okay, normal online class, but for this semester, okay, we start with online first, and we just got the circular yesterday saying that we need to do the face-to-face class, the physical class, okay, meaning that chalk and talk. All right. Okay, we're gonna have our whiteboard there in front of us. If you can remember, I just want to explain. We have a marker, okay, marker pen to write something on the whiteboard, teaching you guys, not using this platform, Webex or Google Meet, okay, or all of that stuff that we have been using them for all 2 years, almost 3 years, right? So now they have stopped that. Okay, the government have decided that we have to move to physical class, face-to-face class, as we have been, went through previously before the pandemic. So it is me or Dr. Aida physically in front of you, not virtually. Okay, so especially to our international friends, we would like to know when you will come to UTM, as the circular have been. Okay, what you say? What you guys said here? Kita jaga kita. Kena bangun awal. Yes, of course. You have to wake up early. Okay, Rosie dah tak sabar. Rosie dah excited kan? Okay. Aida, you asking question there? Dr. Aida, patut ke kita buat poll just nak tahu? Okay, privately. Sorry. Berapa student tak dekat Malaysia? Okay, I think
I dah buat Google Form.
I think it's better to give them, to all of them, to fill up the Google Form, right, Dr. Aida?
Yeah.
Not only for international students, for all.
Yeah.
Alright, so
Saya akan letak the link dalam chat box.
alright. Oh, you have put the
No, I haven't. Nanti
you
I
haven't.
letak.
Okay. You will put that right. I think better in the WhatsApp group, our WhatsApp group. And
Sure,
so
boleh.
we can put it here lah in chat box, because after this we will close, right? So
Yeah.
all right, you guys from Malaysia, don't expect too much, because you can just come here at any time, right? You can walk, you can use a bicycle or anything else, or by hook or by crook, you must be here in UTM. Okay, jogging. Okay, all right. Naik motor boleh, all right. So this is about our lecture. It will be no more online class. Okay, no more WebEx, no more Google Meet after this, unless we have to do so. Okay, and it will be fully physical class. Okay, we can now, after this, Daida, we can see all the students walking here and there, right? Rushing, okay, because wake up late. Okay, we can see all of that things after this. Okay, we missed that for 3 years. Okay, and all of you are from first year or second year? First year or second year? Okay,
Second year, doctor.
second year, right? But you haven't been in UTM.
Currently, for me, I'm staying in UTM already.
Oh, okay, good. So some of you may have the laboratory session, right? The practical course, like labs and anything like that. So you have been here in UTM, okay? But some of you never been in UTM, although in second year. Yes, you can bring your bicycle here in UTM. We have very nice campus to ride, okay? So to our international friends, our international students, so bear in mind that after the Eid celebration, after the Hari Raya, we call it in Malaysia, after the Aidil Fitri celebration, you will be here in UTM, okay, for the physical class. We must have that kind of survey first, okay, because I think it's about how many our international friend here, 5 or 6, right? Because there will be no more hybrid class, meaning that some of lecturers they made that hybrid class, physical and online, but there will be no more hybrid class after this, completely physical class, right? Meaning that I can throw the marker pen when you sleep in the class, okay? All right, so I think that's all for our announcement. Okay, that's all for our announcement. I can see the rabbit running there. Okay. All right. So that is the basic idea of spectroscopy that you have given to me. Spectrum, the radiation, the light, the what else? The wavelength, and so on. All right. Like I said, we have a classical methods that need a tedious lab works. We need to mix all the chemicals, need to measure the weight, we need to do titration very carefully. If we have done mistake during the titration, we need to do it again. That is volumetric analysis. That is a classical methods, right? But now we have an instrumental methods involving spectroscopy technique that we're going to learn today. And then we have also the chromatography technique. We're going to learn this topic, chromatography, after the mid-sem during the face-to-face class, all right? It will be interesting during the face-to-face class, physical class, believe me, right? And we will going to have an electroanalysis methods, okay, using the instrumental methods. Okay, that are all 3 example of the instrumental methods, right? Okay, what is instrumental methods? Methods that exploit the physical properties of an analyte to obtain the qualitative what and quantitative how much. Okay, remember what is qualitative and quantitative. Qualitative is come from the word quality, okay, and quantitative come from the word quantity. So qualitative basically is what type of analyte is that, right? And then quantitative is how much is the analyte. Okay, information by using the modern instruments. All All right, for the spectrometry or the spectrometric methods, it is a group of instrumental methods based on atomic and molecular spectroscopy. Okay. Dr. Aida have given the link for the survey inside the chat box. I think, I believe that Dr. Aida also given that in the WhatsApp group. So I think you can fill that after this. Okay, we shall concentrate on the class first. Okay. A group of instrumental methods based on atomic and molecular spectroscopy. Why we have atomic and molecular spectroscopy? Someone can give you idea why? Don't worry if you if you give a wrong idea. There are no wrong ideas. This is your idea. Your idea is your idea. Wrong or right is not the matter. Okay, we are discussing in the class. So what is your idea? Why? It state here the methods, the instrumental methods for the spectroscopy is based on atomic and molecular. What is atomic and what is molecular? It is important to have a very rough idea before we proceed to the instruments. Someone? I don't want to hear Yap and Eng voice anymore because they they have answered every time when I ask. So I would like to hear from someone else. Okay, now I refer to the chat box from someone who are very active in the chat box. Nicole want to ride the bicycle, okay? When want to ride the bicycle to UTM from your hometown? Or I don't know. Okay, so Nicole, what is your idea? What why it mentioned atomic and molecular? Yeah.
Hi, doctor. So I think because this spectrometry uses as my classmates have said, is like the wavelengths and all that, and those are really in the units of mu meters, So I think that's why it can actually detect it based on an atomic and molecular level.
All right, good. Rough idea about the spectrometry method. All right. Thank you, Nicole. All right. Next, Shafiq. Hi, Shafiq. All right. So, what is your idea about atomic and molecular spectroscopy? Right. Good, Shafiq. Thank you, Shafiq. Okay. The different properties of atomic and molecular in the spectroscopy. What type of different? So we will discuss after this. But the idea is atom and molecule are different, right? Atom are single element. Okay, single atom, a single atom is just one atom. Okay, when it's combined, it will become molecule. So from Shafiq idea, it will have a different properties of spectrum there. Okay, thank you, Shafiq. A good point of view. Now I'd like to ask Voon. Voon.
Hello, doctor. Can you hear me?
All right, I can hear you. Okay, what is your idea about atomic and molecular spectroscopy? Based on atomic and molecular. It's okay. Anything.
Maybe I can talk about why we need to we have such thing which focus in atomic and molecular. I think it's because the interaction of atom or molecule is a quite an obvious factor which will contribute to the changes of something. So that's why we need to study this kind of thing. Yeah, I This is my idea lah.
Yes, thank you so much about the idea. Okay, the difference between the interaction of atomic and molecule. Okay, guys. In analytical chemistry, we need to identify our analyte. So our analyte will be atom. Okay, for example, we would like to analyze iron, okay, in a soil sample. So iron itself, okay, when we want to analyze iron, we are referring to Fe, right? The Fe element. So this is atom. We will need to measure the atom. How much is the iron atom inside the sample? And when we say molecule, okay, molecular. For example, our analyte now is the paracetamol. What is paracetamol? You know what is paracetamol?
Painkiller.
The
It's
painkiller,
Panadol.
right? Okay, it's a molecule. The paracetamol is a molecule. It's not a single atom. Am I correct?
Yes, doctor.
Or you have in the periodic table paracetamol? No, right? You can see in the periodic table. I can show you the periodic table. Okay. Look at my a very nice periodic table blanket from an American Chemical Society. You can see that? You can see that? All right. Can you find me where is paracetamol inside the periodic table? No, because it is a molecule. Am I correct? Let me put my camera back.
Yes, doctor.
Okay.
Yes, doctor.
The molecule is a combination of what?
Atoms.
Atoms. Right?
Element.
So sometimes we want to measure how much is the molecule, okay, instead of measuring how much is the atom. Okay. So that's why the instrumental method is based on atomic and molecular spectroscopy. Atomic spectroscopy will have their different properties. And when we discuss about molecular properties, molecular spectroscopy, we will measure the molecule properties, okay, of in kind of, if, let's say now we are learning spectroscopy in kind of spectrum, the properties in kind of spectrum. So we will do measurement of atoms and also measurement of molecules. And then what is said that spectroscopy is a study, a science that deals with interaction of various types of radiation with matter. Okay. Now, the spectroscopy, okay, we are dealing, okay, dealing with the interaction of various types of radiation. We will set the radiation. What type of radiation we want to deal with? The UV, or UV and visible, or only visible, X-ray, for example. What type of radiation that we want to deal, okay? But mostly in this spectroscopy, we will learn about visible, UV and visible spectroscopy, okay? UV and visible spectrum, okay? Interaction with the matter. The matter now is the analyte that we are focusing, okay? Let's say we want to analyze lead, PB, plumbum, lead, inside a water sample, okay? And then we set some radiations, okay, with some technique to deal with the lead inside the water sample, okay? And then we measure how much the lead, or if you want just to know what type of analyte, okay, is lead exists in the sample. So we just do qualitatively. Is there lead or no lead inside the sample? That is qualitative. We want to measure how much the lead. So we deal with the interaction of the radiation with the lead, and we calculate how much the lead inside the water sample. But to do that, we need to learn how to measure how the atoms and molecules interact with the radiations, and how the measurement involved, okay, in the instruments, in the modern instrument that we are learning now. Okay. So the spectroscopy is a study of the properties of matter through its interaction with different frequency components of the electromagnetic radiation. Okay, so the light, okay, the spectrum is electromagnetic radiation. You can see that from the illustration. Okay, we have the extremely low frequency ELF, we have very low frequency VLF, we have the radio wave, we have the microwave. Okay, microwave is like your at your kitchen. Okay, your mom use that microwave, or you use that to heat your food. Okay, that is microwave. And we have the infrared radiation from the sun. Okay, and also we have the visible light, we have the ultraviolet radiation, we have the X-ray radiation, we have the gamma radiation. That is a very high frequency. From very low to very high frequency, we have a lot of electromagnetic radiation. Okay, this is the type of electromagnetic radiation. Each type of spectroscopy use different light frequency and give a different picture or the spectrum. Okay. So what we can say from spectroscopy is a study of the properties of matter through its interaction with the different frequency components of the electromagnetic radiation. It includes the interaction with the other form of energy. The general methodologies are adapted in various ways to extract information, including the energies. Okay, we're measuring the energy. Okay, the different energy, the absorption, and so on. What kind of energy? Electronic, vibrational, rotational. Okay, what is vibrational and rotational? Can you guys explain, or you have some idea what is vibration and rotation from what? In this case, the vibration and the rotation of the atoms and molecule itself, it will generate some energies, and that is what we're going to measure. Okay, it is unique for every elements. Okay, for example, for atomic, okay, we have a very unique energy, okay, or we call as a packet of energy come out, okay, can be absorbed by every element that we have in the periodic table. That is a very beautiful creation of the creator. Okay, all the elements inside the periodic table give a very specific energy. They are different from each other. Okay, of course, because they have a different electrons number, a proton number, different shell of electrons. All right. Okay, they have a different packet of energy inside. Okay, uniquely for every element. That's why we can differentiate. Okay, we can analyze using the spectroscopy technique. Okay, because the energy, okay, the spectrum that can be released or absorbed by all the elements are very unique, very different from each other. Okay, the structure and conformation of molecules. Okay, with this technique, if we are measuring the spectrum, okay, from the molecules, okay, we can confirm what is the structure, okay, of the molecules and the dynamic properties of atoms and molecules. Okay, meaning that the properties of every atoms and molecules itself can be differentiated and can be studied using this spectroscopy method. And what is spectrometry? That previously spectroscopy is the knowledge, is the study itself. But spectrometry is the measurement. Metry meaning that measuring, right? The measurement of intensity of absorption of what? Emission of what? The light or the spectrum or the radiation. Or scattering, okay, of light, radiation by matter using electronic devices. Okay, now from the spectroscopy study, we have the spectrometry technique, okay, the instruments, the measurement technique. Okay, using the electronic device. Okay, this device can measure the intensity of absorption or emission or scattering of light by the matter. The matter is what? The analyte that we're going to study. Okay, a photometric device as in spectrophotometry. Okay, remember, flashback about the wave properties of electromagnetic radiation. In electromagnetic radiation, okay, it is a form of energy whose behavior is described by the properties of both wave and particles. Okay, from peak to peak is the wavelength. Okay, this is the direction of propagation. Okay, this is the vibration. Okay, optical properties are explained by describing light as wave. Now, in this spectroscopy study, okay, and also spectrometry instruments, the optical properties of all the light involved, okay, we describe the light, okay, that we are dealing in this spectroscopy study as a wave, okay, as a wave, visible or UV or IR or anything else, we consider as a wave now. Okay, the interaction between radiation and matter, okay, for example, the absorption or emission are described by treating light as a particle. Now, the light, okay, involved in this study, we are considering them as a wave and also as a particle, so that we can know or we can understand the step involved after this. We have the absorption, we have the emission, okay, of light. Now we consider the light as wave and also as a particle. So that we can understand. After this, we're gonna learn all the instruments. Right. Light is characterized by a frequency and a wavelength. So what is a wavelength? Lambda is the distance of one cycle. The frequency is the number of cycles passing a fixed point per unit time. Okay, lambda equal to c over v, where c is the velocity of light. Electromagnetic radiation consists of quantum of energy. Okay, this one that I have mentioned to you previously. A quantum of energy or a packet of energy, a discrete packet of energy or photons, we call it. Okay, in the scientific terms, it is called as photons, a packet of energy. During the interaction with atoms or molecule, the energy wave behaves like a particle. Okay, E equal to h mu. Okay, where h is a Planck constant, or E equal to hc over v, if the wave number v is 1 over, oh sorry, mu, we call it mu, not call it z, 1 over lambda. The shorter the wavelength, the higher the energy. This is why UV radiation from the sun can burn. Okay, the shorter the wavelength, the higher the energy. You have learned this, right? So this is why the UV radiation inside various radiations inside the sun light, okay, can burn. UV can burn, especially our skin, because the wavelength is shorter. Now from this slide, you can understand we are dealing with light, but we are considering the light as a particle. And can you understand the discrete packet of energy or photons? Like I said, all elements inside the periodic tables, okay, they have their own packet of energy or photons. They can absorb a packet of energy that's very unique from others. They can emit a packet of energy which are also unique from others. Okay, that is a packet of energy. Wavelength and frequencies of the electromagnetic radiations. Okay, you have learned this previously during your school time. So why is spectroscopy useful in analytical chemistry? Because it is a technique used for detection. Now, in analytical chemistry, we are dealing with any methods to detect or to analyze, okay, how much, okay, or what is inside the sample. Okay, so the spectroscopy is useful because it is a technique used for the detection. In this case, for the analyte inside the sample. And spectrometry, or the spectrometric methods, is a group of instrumental methods using the spectroscopy technique. Okay, it is a group of instrumental method. We have a lot of instruments using this or utilizing or applying this spectroscopy study or knowledge. Now, okay, there are three types of interaction of matter with electromagnetic radiation. Absorption is to take up what? Okay, a transition or excitation from a lower energy state to a higher state with a transfer of energy from radiation, a radiation field, for example, flame, to an absorber. Example, atoms of a metal. Okay, to excite. Okay, for the electron to excite from a lower energy state to a higher energy state. Okay, it will absorb the energy. So the absorption happen when the molecules or atoms, okay, absorb the energy. It will transition. It will excite from a lower energy state to a higher level energy state. Okay, emission. Okay, a relaxation stage is when the electron from higher energy state reduce or go to the lower energy state. It will emit a packet of energy or a light. Okay, meaning that relaxation from a higher state, from the excited state, okay, with a lot of energy, and then when the atoms or molecules go back to the lower energy state, it will release some energy, a packet of energy. Okay, either absorb or emit. Okay, it is different, right? Absorb is take the energy, emit is give back the energy, right? And scattering, a redirection of light due to its interaction with matter. Scatter, okay, redirection. It might or might not occur with a transfer of energy. Okay, or it might and not might, sorry, it might and might not have different wavelength from incident light. Okay, just a scattered, not absorbing or emitting light, but it scattered the light. The redirection of light. Okay. All right. So the light, okay, that we deal now, light we consider as a particle. It can be absorbed or to take up by the analytes. In this case, our atoms or molecule. It also can be emit. Okay, the energy can be emit. Okay, so either absorb or emit. Okay, or scattered. We can measure how much is the amount of energy that have been absorbed, emit, or scattered. Right? The absorption of energy by lead, for example, Pb, okay, is different, okay, from the absorption of light absorbed by copper, for example, Cu. That's why we can differentiate. Is this amount of energy have been absorbed, okay, by a copper? So this is the concentration of copper. But how to apply the concept of spectroscopy in this spectrometry instrument to measure how much lead, for example, inside the analyte? Okay, lead, okay, or all elements, like I said previously, only absorb, okay, or emit a packet of energy that are unique for them. If we want lead to absorb a packet of energy, we should supply the same amount of energy to lead. So when lead atoms introduced to this packet of energy, they will absorb the energy. If the energy, okay, when I mention energy is also similar with light or particles that we have said previously. Okay, we are now dealing the wavelength, or sorry, the light. Okay, the electromagnetic radiation we consider as a particle. When we supply a similar particle that can be absorbed by lead, only lead in the sample can absorb the amount of a packet of energy or the particles. Now, if the packet of energy is not for lead, it is packet of energy that's similar with a copper. When we supply that packet of energy, only copper can absorb that packet of energy. Lead will never absorb that packet of energy. That is the unique of every atoms, okay, or metals. Okay, can you understand that? Oh, am I alone here?
Understand,
You can
Doctor.
understand? All right. So meaning that, like I said, every element have their specialty. They have their unique packet of energy that they can absorb or emit. Okay, meaning that when we supply, okay, a packet of energy that is a very unique, that only can absorb by I give another example, only by aurum. Okay, the gold. Okay, only gold can absorb that energy. Iron or what, palladium, platinum, they can never absorb that packet of energy that we have supplied. Only aurum can absorb. That's why we can analyze aurum inside the sample, because we know when we supply that packet of energy that is similar with aurum to the sample, okay, and then we measure at the end of the process how much energy is being absorbed. If the source of energy and also the detector to detect how much is energy being absorbed after pass through the samples, this is the only concept. The details, it will be learned in the single instrument that we're gonna learn after this. If the detector detect there are no energy being absorbed, meaning that there are no aurum inside the sample. But if the detector detect, there are some energy have been absorbed, okay, this packet of energy, the unique energy being supplied, and the detector detect, there was amount of energy have been absorbed. So there are aurum inside the sample. How many? How much aurum? Only can be measured after the calculation of the detector. Okay, and also the instrument itself, after the calculation, then this is the concentration of aurum inside the sample, because this amount of energy has been absorbed, and then calculate back how much is the volume, okay, of the samples, okay, and the computer will translate into information. This is the concentration of the aurum inside the sample. If there are no energy being absorbed after pass through the sample, supplied and pass through the sample, no energy being absorbed, so we can consider zero concentration of aurum inside the sample. Okay, that is the concept of absorption. And now, what is emission? Okay, what is emission? Okay, There are some instruments using the concept of absorption, like I said previously, but some instruments using the concept of emission. The instrument excite the sample first. All the sample being excited, supply the energy. How to supply the energy to the sample? Burn them using flame, okay, of plasma and so on. Okay, burn them, give them energy. So sample being burned, being excited. Okay, a lot of energy being absorbed by the sample, and then naturally the sample will be all the components inside the sample will emit the energy back. Okay, after absorb, it will emit energy back from excited state to lower energy state. When when all the all the elements or molecules, okay, in this case, for emission, normally we use single elements or atoms, okay, not molecules. When the molecules, when the atoms absorb the energy from burning process by flame and so on, and then after some stage, it will emit back all the energy. Okay, so the energy that has been emitted by the atoms will be detected by the detector, because only a packet of energy unique to every element only can be absorbed or emit. So the emission of the energy being measured by the detector. Oh, this is the amount of energy emitted by these components inside the sample. No, you know, sample, we have a lot of things inside the sample, right? Matrix, all the interference and so on. So when the energy being measured by the detector inside the instrument that using the emission concept, okay, the energy being detected, oh, this is the packet of energy being emitted by this particle inside the sample. So this energy is similar with the energy that only can be absorbed or emitted by calcium. So it is calcium. And how much is the energy will be translated into the concentration. Okay, the information will be translated into the concentration. This is the concentration of calcium inside the sample, because this is the amount of energy that being emitted. Similarly, with the amount of energy that can only be emitted or absorbed by calcium. So this is the concept. All right, normally for absorption and emission, it is only used for single atoms or metals. Okay, meaning that the absorption and emission instruments, the instrument that using or applying the concept of absorption and emission of energy is normally for analyzing atoms. Okay, normally when we analyze atoms, it is of course metals. Okay, we are analyzing metals and also nutrients such as calcium, magnesium, and so on. All right, now scattering. A redirection of light due to its interaction with the matter. Now we supply the light. When the light interact with the matter inside the sample, it will be transfer of energy, scattering, and so on. Then the scattering of energy, okay, the electromagnetic radiation will be measured, okay, and will be translated. Normally, the scattering is for molecules, okay, inside the UV visible instrument and so on. We're gonna learn after this in detail, because you cannot imagine what happened to scattering only by the concept. We will learn detail about scattering when we learn about every instrument that we have in spectroscopy methods. Okay. Oh, guys, it's 12:30 already. This is the illustration of energy change associated with the absorption of electromagnetic radiation. For example, okay, E null or E0 is a ground state. All right. and E1 is the first excited state. A is a pure rotational change of far infrared spectrum. B is rotational and vibrational change. This is near infrared. And rotational and vibrational electronic change is invisible, and UV is for C. So C is normally we are dealing in the range of visible and ultraviolet radiation. Rotational, vibrational, and electronic change inside the molecules or atoms. Okay, this is from. Sorry, what happened to the? Okay, here. This is the ground state, and this is the excited state. Let me re-annotate. Sorry. All right. Okay, this is the ground state. This is E now actually. Okay, and this is the excited state. When our matter, okay, for example, molecules or atoms absorb the energy, it will be excited to the excited state, right? So in some instruments, we measure how much is the energy being absorbed to be excited. And in some instruments, using the concept of emission, okay, they supply the energy first, the raw energy, okay, burning process and so on. And then when the I can see my cursor. When the sorry, when the energy back from excited to the ground state, okay, there will be some. Sorry, when the matter, okay, in the molecule or atoms that have been excited and went back to the ground state, there will be some energy being released, okay, and this energy will be measured, okay, and will be transformed into the information, okay, how much is concentration of the elements, okay, inside the samples. So absorption and emission. Okay, again, okay, absorption, okay, emission. Absorption is from ground state to the excited state, and from the emission is the transition from the excited state to the ground state. And what is possible type of transition for ultraviolet or UV and electronic transition? Near infrared, okay, is a vibrational transition. The visible is outer electron. Far infrared is rotational or vibrational movement of the molecules. The microwave is a rotational transition of the molecules. Normally, this one involves molecules. Okay, the far infrared and microwave involve molecules, right? And these three can be molecules or atoms. Right. This is type of spectroscopy, again, for revision. What is a wavelength? What is a wave number? And the transition involved also different. For example, the gamma emission normally transition is nuclear transition, right? And the X-ray is inner electron transition. The vacuum ultraviolet absorption is a bonding of electrons transition. The ultraviolet and also fluorescence is in bonding electrons as well. The infrared spectroscopy, the transition involves the rotational and vibrational of the molecules. The microwave involves the rotation of molecules. Electron spin resonance involves the spin of electrons in the magnetic field. Okay, this is the different spectroscopy and different transition. And in this spectroscopy technique that we learn in this course, normally involve the ultraviolet Okay. Transition. Okay, and ultraviolet transition, and I think not vacuum ultraviolet absorption. We have only dealing with UV and also visible. This is the methods involved with the properties of radiation, emission or absorption. In emission and radiation, mostly we will learn in this topic. Okay. And also MS, okay, the mass to charge ratio. This we will learn specifically in the ICP-MS instrument. Later we will learn that. But most of the instrument that we're going to learn in this topic involve the emission and absorption of radiation, involving the emission spectroscopy, right? And then also the AAS, okay, instrument, atomic absorption spectroscopy, using the spectrophotometry and photometry, right? No worries, we got to learn in detail in the instrument after this. What kind of properties of radiation that we are dealing in the instruments. Okay, like I said, okay, this most of the instrument using this type of properties of radiation. Right, guys. Before we proceed, I would like to open for Q&A. If you have any question, do you have any question until now? Just yes. Who's that? Who's that? Who's speaking? Again, who's that? Who's that? Awat? Sorry, doctor. Lead is metal. Lead. Yes, not LEAT. LEAD. Lead is a metal. Yes. PB.
Oh yeah, doctor. Just now I
Lead is
checked the spelling.
plumbum. Yes, lead is plumbum. Okay. And just now, who's speaking? I can't hear very clear about the question. Who's speaking? Guys, do you have any question? Just remember the properties of the electromagnetic radiation, the emission and absorption. What is emission? The release of energy after being excited. Okay, come back to the lower energy state, emit some energy, and the energy being measured or analyzed by the instruments, and then being transformed into information. What kind of analyte, and also how much of the analyte inside the instrument, and also absorption. The light source give a packet of energy similar to the target analyte. If you want to analyze, like I said, aurum. So the packet of energy is a packet of energy that only can absorb by aurum. And when the detector detect that the energy from the source has been absorbed by the sample, there's some loss in the energy. So it will transform into an information that the target analyte, for example, aurum, is there in the sample, and how much, depending on how much how much from the energy from the source have been lost, detect by the detector. So transform into an information in the form of concentration. What kind of instrument using that? We're gonna learn after this. We just learn the concept first.
Doctor.
Yes, who's that?
Super good.
Who's that? I can hear.
Super good, doctor.
Okay, yes. What is your question?
Let's say we want to analyze an element.
All right.
And do we use just one technique, or do we have to use a few techniques to actually determine the type.
So Paklit, you're asking about can we use several techniques to analyze one type of analyte?
Like, do we have to use many techniques to determine, or it can be determined with one technique itself?
Okay, thank you, so Paklit, for the question. Normally for the analytes, we can use several techniques, but there will be one technique that is very, very efficient to detect the analytes. Okay, for example, metals. Okay, for example, I always use lead. Okay, because what? Because lead is the most popular pollutants inside the environmental samples. All right, lead can be detected using UV visible instruments. Okay, but also can be detected using other instruments, inductively coupled plasma mass spectrometry, ICP-MS, also can be detected by atomic absorption spectroscopy, right? Also can be detected by another instrument, ICP-OES, but we're gonna learn after this. Okay, even our analyte can be detected by several type of instruments. We're gonna choose perfectly what kind of instrument that we're gonna use based on number one. This topic we're gonna learn. So Paklit, you are very advanced in this question. This topic we're gonna learn at the end of the there is a subtopic at the end of this chapter. Actually, we're gonna choose the instruments based on number one, how much is we suspect the analyte inside the sample. It is you have learned previously with Dr. Aida the ppm, ppb, right? Okay, one question to Supaklit. Okay, before I proceed to the explanation. ppm and ppb, which one is higher in concentration?
ppm.
Yes. Okay, ppm is a part per million. ppb is part per billion. Okay, that is the what we call as is the equivalence, or how to imagine ppb. Okay, it's like a 1 spoon of your blood. Okay, 1 spoon of your blood inside a swimming pool. I think that is about ppm, I think. And if 1 spoon of your blood inside approximately 10 swimming pool, that is a ppb. Okay, that is a very small concentration, right? But for ppm, it is higher than ppb. So if we have the assumption before we choose the instrument, the concentration is in the range of ppm. Okay, the assumption is based on many things, such as there is we take the environmental sample, for example, the seawater sample, because there are of oil spill happened at the one of the beach. Okay, so we take the seawater sample, and we know, of course, there will be lead in high concentration, at least in ppm, because there are oil spill. Lead are a lot of lead in the crude oil. Okay, maybe some of you are petroleum engineers, or no, I believe, because previously, my last class, previous semester, I'm teaching the petroleum engineers. Okay, they know about crude oil. They should know about crude oil and everything. So by your knowledge, you should know that in the crude oil we have a lot of lead. Okay, if the oil spill happens, of course there will be lead polluting the seawater. So your assumption now, the lead in the seawater is at least in ppm level. So in the list of instruments we have from highest. This is not about the choosing the instrument because what instrument do we love to use? No, because the instrument we have the cost of analysis. We have the high cost of analysis per sample. We have also the least cost of analysis per sample. But at the first stage, we want to know how much is the sample. If the sample is ppm, we should use the instrument that can detect in ppm. No need to use instrument that can detect in ppb level, because it is a very high-end instrument, involve a lot of cost. So we don't want our analysis to be very costly, and but we can do this. We can do that even with a cheaper instrument. So we choose perfectly based on the number one is our target, our sample. We suspect how much is the concentration range, and after that, number two is what is our budget, of course. Okay, what is our budget? So based on that, okay, is our sample can be detected or not using the instrument, and what is the budget, okay, and we should use what type of perfect instrument for our sample, okay. Not only select by random, we should know the nature of the sample, okay. Also, because some of the sample are really difficult to be analyzed using, for example, the sample have a lot of interference, okay. So it will be better to use a very high-end instrument. The sample itself is also containing a very low concentration of the analyte, so we must use the instrument that can detect a very low concentration of analyte. So there are some considerations that we need to be involved in our criteria to select the instruments. We're gonna learn that after this. Okay, but it is a good questions from Supaklit. Okay, not only one instrument can detect our analytes. Okay, there might be one or two or three or more instrument can be used to detect our analyte, but we need to choose it. In a very specific criteria. Okay. Okay, Sparklet, understood?
Okay, doctor. Thank
All
you.
right, thanks. Okay, what else? Do you have any other questions? And you can start filling the form that given by Dr. Aida for us to survey how ready we are now to do the face-to-face class, and for Supaklit to book the flight ticket.
Already booked, doctor.
Already booked. That's good.
Yes.
Okay. Island. So from Bangkok to Johor Bahru is not so far. I've been there to Bangkok. For some research activities at Chulalongkorn University, and I have some window shopping there at Bangkok. Okay. To visit several nice place, including the palace. Okay, at Bangkok, very nice city, a very nice city. Next time when I go to Bangkok, I should call Supaklit to guide me.
My pleasure, doctor.
All right, thank you. Okay, our friend from Indonesia, Nabila. So, what is your plan to come to Malaysia? Also, not so far.
I'm come after it.
After a celebration, we'll come here to
Yes.
ETM. That's good. Which part of Indonesia are you now, Nabila? Which province?
Jakarta, West Jakarta.
Okay. From Jakarta to Johor Bahru, do you have any direct flight, or you need to transit to Kuala Lumpur?
Yeah, we need to transit to Kuala Lumpur.
How many hours from Jakarta to Kuala Lumpur?
Maybe 2 hour.
2 hours. And from Kuala Lumpur, if you come here by flight to Johor Bahru, it's only about 1 hour and
Yeah.
maybe shorter than that. If the
Yes,
pilot put the very high speed, we can be in Johor Bahru less than 1 hour. Or you come here by bus, it takes about 4 hours. Okay, if you combine your flight
Yes.
times from Jakarta to Kuala Lumpur, and plus your bus time or your flight time to Johor Bahru, okay, it is a shorter time taken by you, Nabila, than me from if I'm going back to my hometown at Kelantan, okay, by driving. It is about 12 or 11 hours. Meaning that this is very, you are very close to, we are very close. Indonesia and Thailand are very, very close. Okay. In fact, I go to Thailand only by walking because my hometown is Kelantan. I just walk through the borders at the Sungai Golok. Okay, cross the border by only by walking to have some nice foods at Thailand, at the southern Thailand. Okay, also I've been several times to my next neighbor, Singapore. And now the border is open, so I can be there to have my nice food and do some window shopping there, right, Dr. Aida? Let's go to Singapore. But we need to go to Jakarta and Bangkok first to meet Nabila and Supaklit there to guide us to the very nice place there. I haven't been to Jakarta. I haven't been to Jakarta. I only I've been to Surabaya, Medan, Aceh, but I haven't been to Jakarta yet. We'll go one day. All right. So our friend Bara at Turkey. So when you plan to come here to Malaysia?
Actually, doctor, I don't know. I put my plan depend on that lecture will be fully online, but now I should change my plan.
Yes, you should change.
I don't know.
Because we just know about this yesterday, Bara. We also quite shocked about that because we are told that this whole semester will be online class, but when the government declare the phase of pandemic transformed to endemic, and the ministry also declared that need to transform to face class, but it's okay. Just fill the form. Okay,
Yes,
if we don't have the plan or you, yes, if your plan is not this semester, just fill the form because we need to present it to our director to say that are we ready or not to do the face-to-face class.
Okay.
But hopefully we can do that, the face-to-face class. But
Inshallah.
if, for example, Bara cannot come here, we cannot do that. Okay. So we need to pretty sure that all our students can join the class. We don't want to miss anyone. No one left behind. Okay. Right, Bara? Yeah. Awad, what is your plan to come here?
Hi, doctor.
Hi.
So basically, I'm like Para. I was shocked about the.
Yes, you're shocked about this.
So sudden.
We also.
So I don't know. Just now, I think about it if I will continue or book a flight. So I will see later.
All right, that's okay. Is there another lecturer I have told you about this? Not yet.
Not yet, doctor. Not yet.
Right. I believe that all lecturers that teach you in this semester will discuss about this. So I think you better make a plan, or what is your suggestion to all the lecturers? Okay. We are not forcing you to come here. We just tell you what is the situation right now, and that's why we do some survey. You can fill the form so that we can discuss it with our director and so on. What is our next plan for this course? Okay, Awad?
Okay, doctor. But mostly of the school of UTMs, they decided to be online, doctor, like the civil engineering school.
You are from civil?
No, I'm not. I'm from chemical engineering, but civil.
Okay, of course, you are from chemical, but one of your course is from civil, like that.
Actually, I know a friend. He's in civil. Yeah, he said it's fully online.
Yes.
For their course.
That's why you need to fill the form. You just tell what is your, circumstances, what is your problems to come here. You are not booking the flight yet. You are not ready to come here. You just tell us in the form as the proof for us to present to our director. Dr. Aida, do you have any part of the question that telling them to choose or to say something about what's their plan, what is the problems to come here?
No, not at the moment, but I can edit in the form.
All right. Dr. Aida will edit the form. for you to feel what is your plan, what is your problem to come here. You must say that in the form clearly, because we are not forcing you to book the flight now. Come no. Just telling you what is the situation and what is your plan. If you have some obstacles or problems to come here, please tell us. Right, Awad, Bara?
Okay. All right. Thank you, Doctor.
Okay, because you are quite far from Malaysia, you are from Turkey and Saudi Arabia, right? Of course, you are not ready to leave the nice food there, right? To come to Malaysia. But we also have the Arabs and Turkish restaurant here. Don't worry. All right. And do you have another international friends? From Somalia, our friend Muhammad Abdullahi, right?
Yes.
Muhammad Abdullahi. So what is your plan?
Really, I don't know. I am kind of shocked because, I was in Malaysia for before the COVID. I attended foundation here.
Okay.
Same
Okay.
space.
You was here previously.
Yeah, I was here for like 2 years and more than 2 years. And every semester, I will see a letter that saying it will be face to face. So I took it seriously. After there, I delayed my break to go back home because at that time it was very expensive with the tickets, with the quarantine. But this semester, UTM said it will be online. I thought maybe they will change. When I went back, I think it got real, and they are saying there's no more face to face online. It will be face to face. So I feel a bit unlucky, but Alhamdulillah.
Alhamdulillah. Okay, so Muhammad, you should have your plan, and whatever it is, you just fill the form. Tell us, okay, in the form, what is your obstacle, what's your problems, okay, and
Okay.
just let us know about that. Okay.
Okay. Okay.
All right. Only Muhammad, Bara, Awad, Supaklit, and Nabila. Okay. So if you don't have any question, I think we shall continue tomorrow with our lecture on spectroscopy. We're gonna learn a few more about the method itself. Right, and then we will go directly to the instruments. What kind of instruments involved? Okay, and also the Beer's law is very important in spectroscopy. Okay, the Beer's law, Beer-Lambert's law. All right, guys, that's all for today. Thank you so much. And then don't forget to fill the form, the survey, in accordance to the latest announcement by the Ministry of Higher Education and also by UTM, our university, that we're gonna have the face-to-face class, a physical class, after the mid-sem break, which is starting from 9th of May. So what is our plan for our class? Okay. We have 73 students. I think we should learn together in the football field. There is a lot of us. Okay, I don't think we have 73 capacity of class. Yes, better, right? In the football field, bring your own chairs there, and Dr. Aida will bring the whiteboard. Okay, I just bring the marker. All right. I think your faculty, your school will provide the facilities for us to go. Normally for SSCK, we can play football together or after class, right? Or before the class. Okay, good idea. Right, guys. Let me tell you this. I know most of you love to do online class because you are listening to us while you are sleeping. I know that. Okay, you are listening to us while you all on your vacation, right? On the boat, the selfie, TikTok while you have another phone there for class. I know that. Okay, you love this online class because you can play your online game while you have me mumbling there on your other phone, right? Kantor ya dah. Okay. I know that you love this pandemic type of class, but believe me, previously before pandemic, we have a very a wonderful moment of face-to-face class. Okay, we have I bring along an instrument to teach you in the class, right? What is the concept of instrument, and then I bring you to the lab. Okay, and we have some visits and so on. That's a very interesting session during face-to-face class. Okay, and then we have at the end of the class we have a makan time. Okay, we have the celebration. We eat together. Okay, I bought some pizza. This is very wonderful, rather than the online class. So be prepared for that. Inshallah we will meet someday after the celebration or after the makan. Oh, makan suka lah Krista. All right. While eating, yes, we gonna have lecture while having a cup of coffee and a slice of pizza together. Okay. All right. So I think what is being announced by UTM and the ministry is expected already, because it is now Malaysia is in the endemic phase instead of pandemic phase. Make sure you all have your fully dose of vaccine. You are already vaccinated. Okay, we don't have any anti-vaccine here in our class, right? So this is the only solution for this virus now to protect us. At least you have the 2 dose of vaccine, right? And then we're gonna start the normal life together for us in the university, inshallah. Okay, thank you so much, Dr. Aida. Do you have anything, something to say? You have something to say? Don't forget, guys, to fill the form. This is for us to prove our director. Dr. Aida, you have something to say?
Oh, no, nothing from me.
Okay. Our class rep, Eng?
No, doctor.
Oh, who's that behind you? Which one is Eng? Oh, that one is Eng, not the behind one, huh? Because this is too handsome. Okay. What is on your face, Eng? This is how the pandemic class end. We have a lot of
Very
things on
kindness
your
of you.
on the student face and background and so on. All right. All right, guys. Thank you so much. Enjoy your lunch. See you again tomorrow. For those who are fasting, please don't have your lunch. Okay. Right. Assalamualaikum and bye bye.